And welcome viewers to the Smash News Network, least busted name in news. Super excited to bring to you another daily space weather video today. We've got an active region rising here in the southeast as well as a sunspot forming in the northeast. Here it is in 1700 angstroms. There were umbrae when we did show prep. Here's another view. This is 94 plus 171 angstroms. All of that from the Solar Dynamics Observatory. Here's a colorized magnetogram to see that sunspot growing. So we may leave the realm of zero sunspots today. That active region not showing its fields yet. It's expected to rise sometime late today, maybe early tomorrow. There's some more imagery of that. And here's a full disk view. There still is a coronal mass ejection watch in effect. We may upgrade that to a warning later today. Stay tuned at smashomash.com/smashteam for the latest in that. Quite a bit of filamentary material at the moment, such as this large filament up here in the north. The radio flux is only at 76. Here's a one-year chart of the radio flux. The black line there is what we're talking about. The red line is the sunspot number, which has been at 0 for the past couple of days. Space Weather Enthusiast dashboard forecasting a coronal hole wind stream. So here you can see midday on the 13th, we're expecting an uptick in the density, followed by around midnight, an uptick in the solar wind speed. Yeah, it's a coronal hole wind stream forecasted there. Again, it's on the Space Weather Enthusiast dashboard. You can look it up yourself if you like. Continuing on to look at global seismicity. Really what's going on here is a lack of 7 magnitude quakes. We've only had 2 of them in the past 90 days, as you can see from this bar graph from volcanodiscovery.com. Let's roll up the list. No major quakes over the past 24. Nothing in the 6 magnitude range. So we did see a 5.2 north of New Zealand. Continued activity off the coast of Oregon, such as this 4.5. Also some activity in the Aleutians. We'll get to that momentarily. 5.0 magnitude deep quake at Indonesia. Struck at 150 kilometers estimated depth. So in the Rat Islands, there's been a 4.5. South Sandwich Islands continues to shake with a 5.0. And a deep quake in South America there. It's only a 4.8 magnitude, but nearly 200 kilometers depth. Mariana Islands also saw a deep quake there, a 4.9 magnitude. Also, Argentina saw a deep quake. I'm starting to learn the names of towns in South America from covering earthquakes. So let's check volcanoes as we've got some new entries to the list here. La Palma continues to erupt in an explosive fashion, producing a steady 8,000-foot plume of volcanic ash. Please don't pull Volta Caldera. Davidoff in the Aleutian Islands has showed a 4.2 magnitude magmatic quake there, and the alert level has been upgraded to yellow. Davidoff, perhaps ready to erupt. Semisa-Pochnoi, also in the Aleutian Islands. Unreported ash plume size, but apparently a short-lived explosion happened there. Fuego exploding, producing a 15,000-foot ash plume over Guatemala. Nevado del Ruiz, 20,000-foot ash plume over Colombia as it explodes. Sangay, producing a 21,000-foot volcanic ash plume over Ecuador. Through its explosive activity, Revenador in that same country, 15,000-foot ash plume from Revenador. Sabancaya, continuous emissions of gases out of the Peruvian Sabancaya volcano. Nevado State, Chilean, 12,000-foot ash plume as it explodes. Please do not pull Volta Caldera. Please do visit the links below the video. Today's featured product is Vaccinate This. HIPAA, my vaccination status is none of your business. We've got the socks. Smash staff loves them. They're quite comfy as well, by the way. And the print quality is just very high. Congratulations to everybody who's realized that we sell merch. You can find, again, links below the video as well as on the homepage at smashomash.com, as well as links to the Smash team. Give the gift of gifts this holiday season. We've made a bunch of posts free for all to view. So there are some solar GIF animations for you if you like. A bunch of free posts going up through the remainder of 2021. Again, you can find links at the homepage. Welcome to the Neo-Renaissance. Science, it's a rabbit hole. Once again, congratulations on realizing the channel exists. We assume algorithms did not help. Next, the GOES magnetometer over the past 3 days. Some pretty wild swings here in the readings there on both satellites. Just before midnight local time for the GOES 16. And those arc-jet moments, those are the satellites turning on their thrusters to maintain their near-equatorial geosynchronous orbits. It affects the magnetometer readings, possibly when plasma is created by the engines, so they list it on the data. They're not hiding data, folks. They're just not hiding data. Next, the top view ecliptic plane field plot. Earth remains in a south pole current sheet shown here in red. No surprises there. The data is derived from 51 ground-based magnetometers, which is all part of the National Sunspot Observatory. There are also magnetometers on stereo A here at Lagrange 5 and stereo B at Lagrange 4 to get this data. Here's a line of sight view. Again, no named sunspots, but we'll be watching that area in the northeast. Next, your coronal hole line of sight plot. This also shows you the sun's B field in blue. Those potential field surface source lines there. And you can see some south pole oriented coronal holes there in the east. And here's a visualization of the coronal hole situation in 193 angstroms. How about a close-up? There's a great view of a coronal hole. And for you new viewers, you may not be aware that there are high-speed solar protons blasting out of this coronal hole at the moment. Mainly hydrogen nuclei. And let's continue on. Likelihood of flares is not that high. Keep in mind the magnetic environment can change with basically no warning. Since we don't have any sunspots at the moment, that newly formed umbra needs to be around for about 12 hours to be named. And just that increase alone increases the probability of solar flares a little bit. Likelihood isn't that high. Likelihood of coronal mass ejections is high. That's why we have a watch in place for the last couple of days. Here's the flaring profile over the past 3 days. No major flares. Nothing even in the B class range. Although we do see a ramping up here over the past about 36 hours. No big spikes in the proton flux there. No surprises there. No major flares sending relativistic particles our way. Let's look at the real-time solar wind. We've seen a very weak coronal hole wind stream here. Solar wind density is still slightly elevated here at 12.5 protons per cubic centimeter approximately. Solar wind speed very low here at 300 kilometers per second. It doesn't get much slower than that for the solar wind speed. KP index, a measurement of global geomagnetism, here is at 1. There was a NOAA expectation to get to a KP of 4, geomagnetic unrest. That never materialized. KP 1 is the current condition. Let's take a look at the magnetohydrodynamic pressure over the past 4 hours. And this is mainly driven by the solar wind density at the moment, not the speed, since it's so incredibly low at 300 kilometers per second. Nothing to write home about there, pretty unremarkable. Next, the ground magnetic perturbations. That was the geomagnetic moment from space. This is the geomagnetic moment on the surface of the planet. Geospace delta B would be changes to Earth's B field. And we don't see any major geomagnetic perturbations happening here over the past 4 hours. Let's take a look at some more stuff. How about a diagram of the solar system? We're approaching a full moon. We're about a week away. Let's advance this a week. And there's where things will be in a week on December 18th, 1 week from Christmas. Next, a star chart. And we've got Mars here having risen up on the ecliptic recently, which is that yellow line here over Lehigh Valley, Pennsylvania, which is where Smash Staff and I are located. The blue line you see there at the bottom, that is the galactic plane. And the website we're using here is in-the-sky.org. Let's take a look at our coronal mass ejection watch. Since we've got views here from Stereo A at Lagrange point 5 and the Soho Lasco C3 at Lagrange point 1. Stereo A here on your left, that's Lagrange point 5. Soho Lasco C3 on the right, that's Lagrange point 1, between Earth and Sun. And again, we may have to upgrade our coronal mass ejection watch to a warning today. Stay tuned to the channel and smashamash.com/smashteam for the maximum detail. So we're going to do another cosmology segment today. This one will be brief. Make sure you check our playlists. There are over 200 cosmology segments in our playlists at youtube.com/smashomash/playlists. Today's random number is 874. I'm not sure how random it is, but it coincides with this XRay binary here, known as XTEJ1901 plus 014. It's, again, the 874th entry here at the Neil Gehrels Swift Observatory. On the transients page, there is the X-ray output, the hard X-rays from XTEJ1901 plus 014. Interesting moment here back around 2018. It looks like it shut off. It stopped sending X-rays for a little while. Interesting. Otherwise pretty consistent, it looks like. And there's a 30-day chart in the lower left. Let's take a look at it visually. Here it is in X-ray. This is the view from the XMM Newton, a very good X-ray survey. And it's a pretty interesting looking X-ray source there. It's a little bit oblong. Not that surprising considering it is an X-ray binary. How about some other wavelengths? And interestingly, here is the ultraviolet portion of the XMM Newton survey, and you can see not a lot to show there. Not much of a signal at all in ultraviolet. And what's interesting about that is that this object, this X-ray binary, is only bright in very narrow bands of the electromagnetic spectrum. As you can see here, just 3 very narrow bands are where it shows up. I find that very interesting. Is it because there's an alien civilization hiding behind this X-ray binary? I don't know. Let us know in the comments what you think. As if I were an advanced extraterrestrial intelligence, I would hide behind an X-ray binary. That way you wouldn't be able to see what I'm doing. Next, part of the optical survey here from Pan-STARRS bands Z and G. Let's see if we see anything, and indeed it is quite dark, optically speaking, at this X-ray binary. And last but not least, here's the 2-mass infrared survey. Looks like some hot stuff close to it, at least. Anyway, that's today's, quote, random, end quote, object. Again, it's at the Neil Gehrels Swift-Bat X-ray Observatory number 874. It's XTEJ1901 plus 014. There are a lot of objects out there. Some of them are pretty weird. And in cosmology, the only way you can gain skill is to get to studying individual objects, as they have a tendency to refute widely accepted theories when it comes to cosmology. Today's apod.nasa.gov photo, the astronomy picture of the day, is the December 4th solar eclipse from Antarctica. And we've got some people in this image. They are from left to right: Brandon Amat, Aman Chokshi, Cheng Zhang, James Bevington, and Alan Forster. This is the South Pole Telescope, and this is the BICEP Telescope. Again, that's the astronomy picture of the day from Antarctica. Leave us a comment if Antarctica is on your bucket list, as it is mine. That's today's cosmology segment, once again integrated into the daily space weather video. It's incentive to watch our daily content, because many of our cosmology segments are not on the playlist at youtube.com/smashomash/playlists. Next, charging hazards. And we ain't got none. We ain't got no charging hazards, okay? Here's the electron flux over the past year as reported by Solon.info. And we're seeing higher than expected levels here, at least in the past 24 hours. And there we see a typical cratering that we see with coronal hole wind streams as forecasted. The electron flux has dropped off. Although we are still waiting for a more significant velocity increase. So expect to see the solar wind density drop and the solar wind speed come up promptly here in the next, well, really at any moment. Next, the relativistic electron forecast model. And you can see the model is, the forecast is agreeing with what I've said. The yellow diamonds are the observation. The green boxes are the forecast. Next, we're going to show you the total electron content for approximately this region, the area between your GPS satellite and your handset at the ground level. It's the total electron content forecast, which shows you the most likely spots for GPS errors. Now, they usually occur around the equator at noon, but when we see coronal hole wind streams on set, there's a tendency to see a little bit of chaos here, such as nighttime GPS errors and so on. I'll let it play through a second time here. The total electron content forecast. And it is pretty accurate. We have verified this on the Instagram page at instagram.com/smashomash. You can find posts about this a few months ago, actually. Next, the F ionosphere layer. It's the bridge between Earth and space, located at about 300 kilometers of altitude. And here is your ionogram, courtesy Australian Government Bureau Meteorology. Keep in mind this only shows 1 megahertz of resolution here. Each color blob represents 1 million vibrations per second difference. Next, the anomalygram, and we're seeing some pretty stark anomalies here. This is anomaly in megahertz from the 30-day median. So some pretty wild swings happening here, and some low frequency and high frequency anomalies here associated with the southern portion of the planet. Areas around Antarctica. You can see some pretty significant changes here as we approach the solstice. Only about 10 days from the solstice now. And let's bring up the latest image. That's 12 o'clock universal time on the ionogram. And there's 12 o'clock universal time on the anomalygram. Let's do bonus features. Bonus feature number 1 is the Cerro Tololo ground-based solar observatory. Again, filaments, and I think we've got some clouds here over Chile at Cerro Tololo's ground-based solar observatory. You're looking at 6,562.8 angstroms. Hydrogen alpha. How about the GO-16 SUVI, which, by the way, is great at showing solar prominences. It's showing some now, especially around the western and northern portions. Again, don't be surprised to see us upgrade our coronal mass ejection watch to a warning today, as it's looking more and more critical as time goes on. Next, the solar intensitygram and colorized magnetogram. Here's this area we were talking about. And indeed, there are some weak umbrae there. It looks less defined than when we did show prep. So let's just assume we're still at 0 sunspots. Here's some additional imagery for you from the SDO of that rising active region, most likely a sunspot. It's been already producing flares despite not even being in the Earth-facing zone yet. We don't even see any umbrae or the magnetic fields yet, and we already see some flaring happening from this. Here's 94 angstroms, and we'll close out the video with a full disk view. By the way, 94 angstroms takes 10 images per minute instead of only 2. It's specifically designed along with 131 angstroms to study solar flares, which means it could be becoming relevant in the coming day or two. In any case, thanks for tuning in. May that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, Least Busted, Name and News.